Hello, thank you. So it's a great pleasure to be here and also an honor and a humble to be here and able to share our vision on programmable network architecture. Before going into this, let me introduce myself and the company a bit. My name is Eduard Metz. I'm a network architect within the CTO office of KPN. KPN is the incumbent operator in the Netherlands. To give you a bit of a sense of scale, also a sense of scale I learned yesterday. Actually, there are more inhabitants or more people living in this city than we have in the entire country of the Netherlands. So that's kind of to give you a view on the size of our population. So KPN, we actually know there's about 70 million people there. We have about 6 million mobile subscribers, about 3.5 million fixed line subscribers. In our access, for the fixed part, we mainly have copper and fiber access, so it's copper up until a few hundred megabits per second and fiber up to 1 gigabit per second. So that's a bit of a background on the company. We'll now go into the architecture part, so the open programmable architecture. But before going to really into that piece, first a bit background of what we've done in the past years. So for a few years already, KPN has a strategy to simplify, grow and innovate. And that strategy applies to every part of the company, whether it's IT, whether it's the human resource part, whether it's the structure of the organization itself, and also the network. So in the past years, we spent a lot of effort to simplify our network infrastructure, meaning that we previously had different infrastructure for different services, for different purposes. So we had an infrastructure for residential, we had an infrastructure for mobile. And over the past years, we had put a lot of effort in converging all of these infrastructure into a single network infrastructure. We're close to completion on this. And this is also the thing we're building on right now in the architecture vision. In parallel, or it's a next step, to be able to grow the infrastructure. We've moved from a centralized architecture and in 4 locations to a more decentralized architecture, allowing us to move. So we moved our edge functions, our B&G functions closer to the edge, closer to the subscribers, allowing us to also move our content and services closer to the edge. So initially, we didn't do this because there was no case for this, there was no business case supporting this. But in the last 2-3 years, we started moving our content closer to the edge. So we started with our own TV services to move them close to the edge as a saving on transport. And now we're also starting to move third-party services like Netflix. We push more to the edge, also to reduce the cost of transport in our network. And then a few years back, we started in the next, so the innovation part in the network. So the big innovation is to virtualize our network functions and our services into a virtualization platform, to move away from dedicated hardware platforms to more generic platforms with virtualized services on top of this, to have more flexibility and more cost-efficient infrastructure. And actually, the programmable network architecture builds on top of this, because we also discovered some hurdles in this. We cannot virtualize everything. So the ambitions in our effort to re-architect the network, we have to set some requirements. So what do we want to achieve? Well, as many operators are struggling with this, we have to continuously increase capacity of the network, provide more capacity to our end users. At the same time, we need to lower our costs, because the revenues do not grow at the same speed. The capacity grows and the cost that goes with that. The other thing is that we want to improve the continuity, so the availability of a network and our services as well. Connectivity has become more important. It has become very important over the past years and will only become more important. So not having connectivity even for residential users is not really an option. So we want to make it more robust, more resilient. And also the changes we need to apply to a network ideally they should not have any impact on services. So they may have impact on infrastructure, but they should not have any impact on services. We spend a lot of effort in migrations, and that's actually kind of a waste, because all this effort we spend on migrations we cannot put into defining new service or deploying new services. And then of course we want to add new functionality, give the network a more real-time nature, so people can access services in real-time, change and build services in real time. Last but not least, we want to improve the circularity, so become more green operator. We already are one of the greenest operators, and we want to keep that position. On the other hand, we have the technology developments that fortunately help us to achieve such a vision. So we defined an architecture based on 4 pillars. Software defined, it's one of the key pillars that should be disaggregate. I think it's distributed and open. To start with the first, so software defined, well, first of all, it means it's a continuation of the virtualization of function. It also means a fully automated architecture in our view. So we see a fully automated closed loop architecture that runs the network. So now we provision network automatically, but we also want events that triggered from the network be translated into new corrective actions or whatever is needed. And actually the new thing that's in there is compared to the previous architectures we had, is that we'd like the infrastructure to be programmable. That has been mentioned a few times already, but we'd like to have a programmable infrastructure because we found we cannot we can virtualize all functions, but it comes at a cost. So we want to offload more traffic heavy functions into the networking layer and keep them there. Then the distributed part. So we already started distributing our content and services to the edge. We want to keep this ability in the network, and also allow the flexibility to even move it further if that's needed. So, as mentioned, Netherlands is a small country, so you can only distribute this much to the edge. Maybe we are already an edge in itself as a country, but we want to be able to push things further out if there's a need. We also think that the distributed topology, so the leaf-spine topology that has been mentioned a few times already, will help us in achieving some of the ambitions we set for ourselves. So leaf-spine, you could easily replace components without having direct impact on services. It allows you to scale efficiently. So that's some of the things that support our ambitions. And then we also, so part of distribution is not only our own content, not only third-party content, but also maybe like Mac type of solutions that are part of the edge areas. And then this disaggregated as a third aspect of our architecture. Well, the whole direction of disaggregation has been ongoing for a while already. We see this as an important thing to decouple hardware and software, to decouple forwarding control, to also there introduce more flexibility into the entire architecture, and being able to swap out and exchange components without having impact on the entire stack. That's on top of it. So now we swap out, for instance, a BNG or a router, and then it has pretty big impact. We want ideally this to be changed, that we can swap out switches without having to impact on the software stack and keep that stable, or the other way around, add components or change components in our software stack without having to change the underlying hardware stack. So this whole disaggregation, it introduces a lot of new flexibility for us. It also helps us drive down the cost because we get hopefully a broader choice in software and hardware solutions. Obviously, you cannot disaggregate, or you cannot disaggregate, but to successfully disaggregate, we need open interfaces, and we actually want open interfaces everywhere. So between all the layers that we want to disaggregate from each other, we'd like an open standardized interface that allows us to actually exchange components in an easy way. So it means open interfaces to the hardware layer, to the data plane layer, but also open interfaces between the software layers and within the software, so we can exchange or add or remove new components to the architecture without impacting, again, the entire stack. It's also open in another aspect. We think open source and open community specifications are pivotal to be able to support this. So the work of ONF has been mentioned already. Open Compute also been mentioned earlier. These are, well, developments that support, that we think are important elements in the architecture we foresee. Already I mentioned some of the solutions there, like Stratum, that's already been discussed, and Owners and Court as well. So these are the, let's say, the main pillars of our architecture. We think these concepts would apply to the entire end-to-end architecture. So we're looking at it right now from an access to a server point of view and the entire infrastructure in between. I will not go into the entire infrastructure, but now we'll have a bit of a closer look at what you call the central office of the architecture. And we see a few components that we see as key building blocks in there, and they could be used in other spaces as well, but in particular for the central office. So first building block or concept is the court, the whole court concept that has been mentioned a few times already. So bringing the data center concept to the central office, along with the flexibility, the low cost. So this is what kind of the basic concept for the central office. And with that also UPen already mentioned, and then in particular the Stratum interface to have a standardized and open interface to the hardware layer that allows us to program the hardware directly. So not only configure the hardware, but also program the hardware. And the programming of the hardware is an important thing to us because we'd like to combine functions in the data plane we're currently not able to combine. For instance, we have a BNG, which does the subscriber management for our fixed, and we have a packet gateway, which does it for the wireline. If you look at them, the hardware is almost identical. The logos are similar, the same. But we cannot combine these things into one box, simply because, well, we're a small player, that's for one, and our vendor has made different choices there. Meaning we have to build capacity twice, actually. So we once build it for the residential, for the fixed, and once build it for the mobile. We want to be able to merge these functions. Also, there is a lot of functions in there we don't need, so these can be left out as well. So it gives us an opportunity to have a, well, let's say, the clean slate switch, and only put those functions in we need in the combinations we would like to have them. So in a more detailed, so the programmable central office. So our network is, we have kind of a centralized part, which is the heart of the network. So the core is 4 locations, and then surrounding that, we have about 160 or we're going, right now it's 200, but we're going to about 160 what we call metro core areas. So this is what I would take here as the central office. So in this metro core area, we have a metro core location, which is kind of the point where all traffic passes for that area. All traffic is aggregated in that area. So starting with the physical topology, so we foresee a leaf spine topology within the location, but also extending into the area, so where the D-slams are, where the cell sites are, to aggregate further out so outside of the location as well. The leaf spine with leaves also outside the location. Compute and storage local within the location to provide local services and decentralized content. Connected to the leaves in the network, we have our access, so mobile and fixed access. We also want to dual home our mobile and fixed access to again improve the resiliency of the network. So if there is one leaf switch failing, we can switch the traffic to the other leaf switch, so again improving the resilience of the network. And we think that with a more centralized approach, so already the leaf switch and the leaf spine reduces the failure radius of the network. Currently we have bigger boxes, so if that fails, a large group of customers are impacted. If we distribute this and disaggregate this into smaller units, we only impact a smaller number of customers. And the centralized controller, controlling the entire network, hopefully also helps to simplify the redundancy. So now it's pretty hard. We can make it redundant, right? But it's a hard task to do so. With the centralized control, hopefully we can also make this easier for ourselves. So then we have a programmable forwarding plane, Stratum interfaces all over the place. To have a unified interface towards the hardware to program it, but also to be able to define the data plane wherever needed. Another way of programming the data plane is the use of segment routing. Segment routing v6 it allows us also in a different way to program the data plane or program data paths to implement service chaining or whatever needs we have to stitch services together using a single protocol layer. Again, in an effort to also simplify the infrastructure. So that's for the transport part, and then on top of that, or next to that, the leaves will also, in our view, have both subscriber or the access part, so the BNG and the packet gateway, we see them converging into a single switch. So both in the data plane, we see some convergence for transport efficiency. So right now, mobile traffic is only a fraction of fixed traffic, but with 5G this may change, so we may experience a shift in traffic, and this shift in traffic should not mean for us to have build capacity elsewhere or build up capacity elsewhere while we already have it somewhere in one place of the network. So ideally, when a user decides to shift massively from the fixed access to the mobile access for whatever reasons, we can reuse the capacity we already have in the network. We don't have to build it 2 times or 3 times as we do today. And also having it in the data plane means that we can, this is the most efficient way of doing transport instead of pushing it all the way to the compute. So looking a bit closer into the fixed mobile convergence part. Well, as I said earlier, so we want to integrate these, the fixed and mobile into a single switch, so we can share the capacity to handle, be able to better handle the shifts in capacity. Also, it allows for the mobile users to be able to access the local content. So now, in our architecture, we have decentralized our content to the edge, but the mobile users are still accessing the centralized content because their user sessions are terminated in the central location, so they cannot actually benefit from having the content local. And for 5G, even though you may doubt some of the use cases with regarding to delay, there may be some cases where there's a need to have more local content or more local services or functions that users need to access. So this also allows to do that without having kind of bump in the wire solutions for the users to be able to access that. So next to the data plane, we also see that we potentially could converge in the control plane. So there's 2 control planes for fixed and wireless, and well, ideally we'd also converge the control planes for fixed and wireless, so we can reuse a function and reduction of functions in the network infrastructure. Again, an effort to simplify further the infrastructure. The less functions we have and need to maintain, the better it is for us. And a potential interesting, maybe even a first use case for this converged fixed mobile could be the hybrid access. So one of the services we're providing is hybrid access for our customers, where they have a fixed access, but also a mobile access. So it's for rural areas or to deliver services faster. And already this traffic volume of this is becoming a large part of all the mobile traffic, so all the mobile traffic in the network. These users, well, they are essentially fixed, so they're not mobile, they're just using the wireless access. So it would be a great opportunity to move these functions closer to the edge and do the transport function, because all they need is connectivity. Do the connectivity functions in a decentral way, and not because right now we're all this traffic is first going to the packet gateway, which is centralized already. Then there is a hybrid access gateway behind that, and it's another gateway. And while the fixed part of the traffic is going to the BNG, which is decentral. So also these users may not always be able to access the decentralized content because it's all tunneled or it's the multipath TCP. So this could actually be a first use case to start some fixed mobile convergence in an open source solution that is decentralized, and then mainly a first case because the users are not moving. So that's also allows a simplification of the first build of such a solution. So this is how we foresee the central office to evolve. So next to the central office use case, we have a number of other use cases, some more elaborate, other more simple, where we foresee the applicability of programmable networks in our network. We try to apply it to the end-to-end chain. Right now we're studying on where to start with this implementation. But to summarize, we see a programmable network that's software defined. It's distributed and disaggregated. It's foremost it's open. So we think the open specifications and the open source communities are very important and key to this architecture. We also joined ONF and the Open Compute project. So we also help further developing all these use cases. A key ingredient of our architecture, at least in our view, is to have the programmable data plane to be able to offload virtual network functions, so that at least the data plane part to have a cost-efficient transport for these, and be able to select the most efficient resources for our transport functions. So right now we may be able to run some of the functions in the compute, but as soon as they become larger, we want to be able to offload them into the network layer again without too much effort. And there's a lot of possibilities for fixed mobile convergence, both in the data plane as well as in the console plane, and also being enabled by the programmability of the data plane that allows us to bring together functions in a single piece of equipment that we are at this point in time not able to do. So right now we're trying to further develop this architecture within the company to move from architecture and designs into more implementation and proof of concept, and we're also looking forward to work with the community to further develop these cases and see where we can help each other to come to a more beneficial and joint effort to make this a great success. So with that, this is my end of the presentation. I'd like to thank you for your attention.